All right, tidal power. So what is tidal power? Tidal power is the energy of the ocean's waves. It's produced by large tidal energy generators that convert the water movement, which is kinetic energy, into electricity. Some fun facts about tidal power is the fact that it was introduced in 1966 by Charles de Gaulle, and he opened the first tidal power station. The first station was located on the Rance estuary in Brittany, France, but it was very small, and um, compared to the tidal energy generators today, you would not be able to tell that that's what it was. Some requirements of tidal power and tidal energy. You need a tidal energy generator. That's what converts the kinetic energy into electricity. You need an ocean, just because it's a large body of water that has waves and tides. You need high tidal movement, so lots of tides, lots of waves, because that's is what is needed to make the energy. Then you need a tidal range, which is at least 7 meters. It's the area that the generator can take the water from to turn it into the electricity. And then you need a tidal power barrage, which withstands the waves that exert too much force on the generator. So this is a tidal powerhouse diagram, basically just the makeup of a tidal power generator. As you can see, it's very similar to a car engine. It has a lot of the same pieces, turbines and runners, but basically it takes the tides and it sends them through the whole system, and it converts it into electricity. So some advantages of tidal power is the fact that it's a renewable source of energy. Water is water. It doesn't just leave the earth. It doesn't really go away. So it's renewable and good for the environment. The turbines used are relatively inexpensive. Just when you're making them or when you're buying the parts, the cheapest turbine was $1,500. The powerhouses produce no greenhouse gases or no other waste. Again, proving that it's good for the environment and really beneficial in that regard. And tides are easily predictable, so therefore it's really easy to tell where you place the generator, making it more efficient. And tidal turbines are 80% effective, which is more than wind and solar energy generators, which are already extremely popular. And the barrages reduce high tide damage on the land, meaning that it's first of all, another environmental positive, but it's also, really good for the generators and for the land off of the water. So some disadvantages. It can be expensive just because of the fact that new technology is more expensive. So while some of the older versions are cheaper, the newer ones and the ones that, do a better job are more expensive. They need to be close to land just because when you construct them, they're big and they're very powerful. You can't put them super far out, because if they do break or if there is like a malfunction and you need to get it back to land to fix it, it can't be super far out. There are a few negative environmental impacts. For example, it has very similar effects to like hydroelectric dams, just because they rely on the manipulation of like the ocean level and the tides. But there are so many positive environmental effects that it kind of balances itself out. So currently, it's being used to convert tides into power, mainly electricity, which I said before. As of right now, it's not a worldwide use of power and energy, but there are stations located in various countries like Europe, Canada, South Korea, and it's starting to become a lot more popular there. And then although the usage is limited, the countries are choosing to use this power, um, are using it for like lighting buildings and factories in area near the plants. So when you're looking at the future of tidal power, it all hangs on the cost. It's currently really difficult for tidal energy to compete with the prices of normal electrical companies just because of the fact that it's, such a complex design. But scientists are still developing more efficient underwater turbines that will lower costs. They'll be more efficient, and obviously, as it becomes more popular, the prices will definitely go down. And then there is a need for more stable generators, because the current generators can deteriorate when the tides get choppy, which is why they need to be so close to land so they can be repaired quickly. But new technology will prohibit deterioration of the generators, but that will probably raise the cost up a little bit, so we're still a few years away from that. And then it could power up to 20% of the United Kingdom if it's deployed efficiently. which is just like a sample size of how, incredible and how useful tidal power can be. So is tidal power a worldwide use of energy? If not, why do you think that is? And do you think tidal power should be used more often? Why or not? Why or why not? If I was to answer these questions, I think it can be a source of worldwide energy, just because so much of the Earth is oceans, and we have so much water, and lots of tides, lots of waves. We definitely can make it work if we wanted to, but again, the costs need to be lowered, and we're still far removed from that ever happening. And for those same reasons, I think it should be used more often, just because of the fact that there are so many environmental positives as well. And then here's our works cited.